To finish up this unit, we're going to look at graphing and solving radical functions and radical equations. So to begin with, we will always look at the parent function. So if we want to sketch the graph of y equals the square root of x, we ask ourselves, I don't know what that looks like. What do we do if we don't know what a graph will look like? We make a table. That is always our answer. That is always the easiest way to see what a function looks like when we don't know what it's going to look like in advance. So if we plug in the square root of -1, well, that gets us our undefined value, and we've talked about imaginary and complex numbers and the fact that this would be a complex solution, but we don't graph complex solutions. So for the purpose of the graph, that's an undefined solution. So that tells us everything into the negatives is going to be undefined. So therefore our graph is going to basically begin at 0. The square root of 0 is 0. And you notice I picked perfect squares for my x values because we can plug in whatever x's we would like. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So these are our points that are going to be on our graph y equals radical x. So we found the points that were on our graph to be 0, 0, 1, 1, 4, 2, and then 9, 3 is going to be somewhere over there. And so as we think about that point, what's happening to our graph here is in order to go up one step, we have to continually go over further and further and further. We went up 1 over 1, then up 3 over 1, then up 5 over 1. You might remember that pattern from a quadratic function in the graph of a parabola. And if you think about this, the shape of our graph is really a parabola turned on its side. If we would stand it up, that would be the side of the parabola. We just finished up talking about inverse functions. And we talked about how parabolas don't have inverses because you get two outputs for each for one of the same input. But in this case, you can look at that graph and see that this is the inverse of part of our parabola function, or part of a quadratic function. So when you think about a square root function, y equals square root of x, the parent function is similar to a parabola laid on its side. It's going to start at 0, 0, go to 1, 1, and then go to 4, 2, where it's going to be flattening out as it goes. So as we've done with every graph we've done in this course, we're going to have shifts upon our parent function. And the shifts are going to be exactly the same as they are with absolute value and quadratic functions. And you see here I've given you a standard form of the equation. Y equals the square root of x minus h plus k, where h represents the horizontal shift. And remember, inside is always the opposite. The formula says minus. So therefore, for a minus, we're going to go to the right. For a plus, we're going to go to the left. And the k on the end is a vertical shift, exactly the same as a lot of the other functions we've worked with. So let's look at our first example. Most of these problems aren't going to take a very long time to do. All we're going to do here is recognize our shifts. This says go right 3, up 4. Again, we've done these before. We're going to go pretty quickly. Right 3, up 4 is where we've shifted our parent function. Then our parent function went up 1 over 1, and then up 1 over 3. So we're going to draw it in so it flattens out as it goes. Remember, it'll never curl back down. It continues to increase. It just gets flatter and flatter and flatter as we go further and further to the right. And for this course, this is as far as we're going to go with graphing radical functions. There are different things we can do where we do things like put a negative on the outside, and if that negative goes on the outside, it's going to have the same impact, where it would flip that upside down just like it did in a parabola. Or the other thing that can happen is if you would plug a negative on the inside of a radical, what that does, and we'll do that one in black, is it flips it back this way. Now, we're not going to have any of those in this class. I just wanted to show it to you so that you got that in case you would see it later on an ACT test or something like that. You'll have at least seen it before. We're also going to graph cubic functions today. Like I said, we're only doing the basic shifts. We're not going in depth into our graphing, so we're going to combine these into one day, graphing radical functions, both square root and cube root. The biggest difference being a cubed root can go into the negatives. So therefore, the cube root of -8 is -2, because -2 times -2 would be 4, times another -2 would be -8. So 3 -2's multiplied together would give you -8. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. Cube root of 8 is 2. And the cube root of 27 is 3. So when we look at that, in order to get to our y value being up 3 units, we have to go over 27 units. So this graph is going to be even more flat than the square root function. Let's look at the graph. As you look at our graph, we're a little bit limited here. This grid only goes to -6, and our first point was at -8, -2. So we'll put it off the grid a little bit there. -8, -2. Then we went to -1, -1, 0, 0, 1, 1, 8, 2, and our final point, 27, 3, is so far over to the right, it would barely even fit on this screen. So when you look at what this looks like, this is very similar to the square root function on this side. It just gets flatter a little bit quicker. The big difference between the cube root function and the square root function is the cube root can go into the negatives, so therefore we continue that graph in both directions, where it looks like our square root function going in both directions. All right, the final example we're going to look at here today is graphing a cube root function with the shifts. The shifts upon a cube root function are exactly the same as they are upon a square root function, so we're not going to go over those. We'll just look at what this means. That's a shift left 2. This shift is down 3, so we go left 2, down 3. And then, if this was a square root function, we would graph this. Up 1 over 1. Well, because it's cubed root, the next step, we have to go over to 8 from our original point, or 7 from our new point, over 7, up 1. And on the left side, we're going to have the graph continuing. This is where it's different from a square root function. It's going to continue down into the negatives, where our graph is going to look like this. It's our cube root parent function shifted left 2, down 3. So when you shift a square root function, we're shifting our starting point. We're shifting where our graph will start is what we shift to begin that. To begin a cube root function, we're going to shift the center point. That 0, 0 point, we're going to shift that, and the graph is going to go in both directions. All right, good luck.